Hello friends from Quantum Club. Today we have a new guest to our program. This is Professor John Corbett from the Macquarie University of Sydney, and we are talking about on Einstein Locality for quantum systems. We are in the Congress Foundation of Physics in London now. Can you say something about your talk?
Yes. Hi. Well, I think one of the talk was about Einstein's suggestion a number of years ago was that in order to do experiments without any interference from other pieces of apparatus, what we have to do is ensure that where we're doing the experiment is far enough away from other sources of disturbance, right? Mm-hmm. So there has to be some distance between them. The trouble was that there was a work done in quantum mechanics where they have done these experiments where they claim that they can affect what happens at one particular experimental station by what happens at another one a very long way away. And the question is, so this seems to put Einstein's principle at risk, and if it does, it means it's very hard to know we measure something, and when we perform an experiment, are we really measuring what we want to measure, or are we being influenced by something else? And so what I was proposing was that with a small change to quantum mechanics and to the standard mathematical formulation of the theory, you can construct a spatial continuum for the quantum systems, which is different from a classical spatial continuum. In these particular experiments, which are done in quantum mechanics, it turns out that the systems involved in those are close to each other in the quantum spatial continuum, even though the experiments are well separated in the classical. And so this is quite an interesting idea, and it brings in the idea that maybe there is a particular quantum regime, which is a quantum space-time, which is different from our classical. So that was what I was trying to explore.
But it was very interesting many years ago when arose the paradox Einstein-Rosen-Podolsky, I think.
Yes,
no?
That's right, yes.
But it's not closed yet.
No, unfortunately it isn't. And one of the troubles that's rather confusing is that in many of the discussions of this, where it's now become mostly they talk about a work by Bell or Bohm's modification of the Einstein-Podolsky-Rosen. I claim that the reason why it's still being discussed is partly because we haven't been able to realize that we really need to take into account the actual physical distance between microsystems is quite different from the classical one. But unfortunately, one of the hard things is it takes people it's easy to make up new theories, as has been said, but it's hard for people to get rid of old ideas. And so we don't need to worry about their spatial development, their spatial environment. One of the troubles is to do it mathematically although the idea is simple, it requires a quite sophisticated mathematics which wasn't developed until the 1960s, 1970s in topos theory, and so therefore, which replaces set theory as a basis for mathematics. And if you do that, but a lot of people aren't willing to spend the time. It's hard to learn a new mathematics unless they're forced.
Professor Corbett, many thanks for your words. I hope see you soon in Chile.
Well, thank you very much. I look forward to seeing everybody there at your club.
Quantum Club.
At the Quantum Club, yes, it would be.
For you, my friends, goodbye until 2 weeks.